Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving maximum count of positive integer and negative integer. So the problem is pretty simple. We want to return the maximum between the number of positive integers and the number of negative integers in the array. So if we look at these three examples, for example 1, we will return 3 because there's 3 positive integers and 3 negative integers. So the maximum among them is 3. In example 2, we will return 3 because there are 3 negative integers but only 2 positive integers. In example 3, we'll return 4 because there are 4 positive integers and no negative integers. So now that we have seen some examples, let's get to how we can solve this problem. So one way, or the brute force way that we can solve this problem, is we can iterate through the array and count the number of positive and negatives, and we will return the higher between the positives and negatives. And the time will be O of n, where n is the number of elements in the array, because we will iterate through the array once. But there's actually a more efficient way to solve this problem, since the array is sorted, so we'll go over that way right now. So a more efficient way that we can solve this problem is we can use binary search to find the number of positives and the number of negatives. Initially, positive and negative will both start as the length of the array, but we can find the number of positives by subtracting the length of the array by the first index of a positive integer. So as you can see, if we do 7 minus 5, it would be 2, and there are 2 positive integers. And we can find the number of negatives by looking for the first index of a non-negative integer. So index 3, and as you can see, there are 3 negative integers. So how we will use binary search is that we will first find the middle value and continue shifting the pointers until they meet. But one catch is that when we choose to shift the right pointer, we also want to update the positive or the negative, and we want to update that by replacing the current value with the middle value. And also one more thing, for when finding the negative, we would shift the left pointer if the middle value is less than 0. Otherwise, we shift the right pointer. For positive, we would shift the left pointer if the middle value is less than or equal to 0. Otherwise, we would shift the right pointer. So now we have the algorithm down. Let's go over this example. So we will solve for the positive first. So obviously first the middle value is 0. 0 is equal to 0, so we will shift the left pointer, which we will do the middle plus 1. So the new left pointer will be right here. Now we look for the middle value again. The middle value is 1. 1 is greater than 0, so now we shift the right pointer, which we will do the middle minus 1, which is right here. And since we are shifting the right pointer, we need to update the positive result. So the positive now will be 2 because the length minus index 5 is 2. And now that the pointers meet, the binary search is basically done. So now let's get to the negative part. So first the middle value will be 0. And since 0 is not less than 0, we will shift the right pointer. And since we are shifting the right pointer, then we need to update the result with the middle value. So the middle value would be 3. And now since we are here, negative 2 is less than 0, so we shift the left pointer. And the left pointer would be the middle value plus 1. So now the pointers will meet. So now that the pointers have met, we're basically done with a negative, and between positive and negative, the negative is larger, so we will return 3 for this example. So the time complexity would be O of log n, since we are using binary search, and the space complexity would be O of 1, because we are not using any extra space. So now let's get to the coding part. So first, we would define the function for finding the negative. So define negative, self, and nums inside the parentheses. So the starting index would be 0, and the ending index would be the length of nums minus 1. And the starting index, or the middle value, the starting result, we will call it the length of nums. And now we will set the binary search algorithm. So while start is less than or equal to end, so the middle value would be start plus end. That's how divided by 2. That's how I find the middle value. And for negative, if the middle value is less than 0, we shift the left pointer. And start equals mid plus 1. And if otherwise, we shift the right pointer, which is the end. And we will set the index to middle. So we update the index. And then we will return index. And the positive will be exactly the same, except inside the if statement, instead of if nums of mid is less than 0, it will be less than or equal to 0. So now we will find the positive and negative, and remember for positive, we need to subtract the length of nums by what we return in positive, which is the positive index, and for negative, we can just return the index, and now we find the max between positive and negative, and that should return the result. Let's see if it works. Okay, perfect. Thank you all for watching. I hope this was helpful. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.